In this video, we are going to create a very basic agent loop with some very simple tools. This is very much what something like Claude Code or whatever is based on. This is the type of thing you're going to see with Pi coding agents and things of that nature. But we're just going to build it from scratch. So what I've got going on here, I've got the AI SDK, I've got AI, I've got Zod, which we're going to use a little later. And I've got this bin here because I want to be able to run this from anywhere on my system. We're primarily going to be working in one file. This is our index.ts. Got a few things we're bringing in from AI SDK. We've got create OpenAI. We've got the generate text command. This is loop finish, which we'll talk about. Model message type. And from Node, we've just got readline, which is going to act as our interface. Set up a couple little constants here. I'm going to be using this model because it happens to run really well on a Mac. We're setting up our API here, calling it Ollama, create open API. Here's our URL and here's our key that we don't really need. We are going to start with our agent loop. So our agent loop is going to be an async function that takes in messages, which will be an array of those model messages that we got from the AI SDK. And then using AI SDK, we are going to say we're going to get the text response from generate text. That guy is going to take in an object. Going to have our model, which is going to be Ollama, which was the API we set up, .chat, and then our model. It's going to have a system prompt. I'll figure that out in a second. Then we're going to send in our messages, which are coming in as an argument. And then we're going to use this stop when. And this is where we're going to use is loop finished. And this is like some real magic. It ends up saving you a whole bunch of looping logic that you would have to build out. This basically says, let the LLM run until it decides that it's finished or until the user says so. The next thing that we're going to have here, and we're going to skip for just right now, is going to be tools. We're going to come back to that because we haven't built those yet. So our system prompt is going to be you are a coding agent at, and then we'll just throw in that working directory. This guy right here, which is our current working directory. That's going to allow us to use this in other directories later. So we'll come back to that. Okay, so once we get past that guy, I think we're just going to return our text. Let's type a return promise of string. There we go. And let's await this guy. All right, our agent loop is looking good. We're going to jump to our interface. Now our interface, like I said, is just going to use readline. So we're going to set that up with rl equals readline dot create interface. And into that, this is pretty much always the same. We're going to have input, which is going to be process dot standard in. Now we're going to have output, which is going to be process dot standard out. Okay, so there's our interface. We're also going to have our messages that we carry around that we're going to end up passing to our loop. I'm going to call that history. I'm going to set that up to be model message array, and for now that's going to be empty. Okay, now we're going to have our prompt, and this is going to be like our recursive function that just keeps coming back to the prompt, like what do you want to do next? So that's going to be a function that just voids this out. Or I'm sorry, it doesn't return anything. And then we're going to use our readline to ask a question. And we're just going to have some sort of generic little prompt here. I'm going to say input and whatever. That's, you know, where we're expecting the user to type something after that. So we're going to have our async. We're going to be passing in, we'll call it our query, which is the message that the user gives us. First thing we're going to do is push that into our history. So if you've seen any of my videos before, this message is right here is usually an array of objects. You have a role, you have a type, and then you have the content, things of that nature. So here we're going to say this role is the user, and the content is the query. So we are going to do that one more time with the little guy in between, but for now this is going to be role is our assistant. So this is where we're going to get our reply. So we'll be sending the reply there. So now we need to get that. So const reply, and this is really easy, is await agent loop history. So we're just passing in all the messages. Nice and easy. Okay, so once we get past that, we're going to say if we in fact have a reply, we're going to log that guy out. And then we're just going to log out an empty line in order to start the next prompt. So we're done, and now we want to prompt again. And then to kick this whole thing off, we're just going to run prompt. So that's essentially going to run forever. We could add in here, like if the query is the word exit or something, to go ahead and exit. But for right now, you just Control-C to get out of this guy. So technically, we could try this out right now. So I'm just going to do that. Let me zoom this way in. Say run index, and we'll see if I mess that up. There's our input. And I say, what is 2 plus 2? And we get 2 plus 2 is 4. Who was the 5th U.S. president? James Monroe, yada, yada, yada. And since we have our history, I should be able to say who was next and who was after him. Cool. The president after James Monroe was John Quincy Adams. I believe it. I don't know if it's true or not, but that's not why we're doing this. But either way, we have a groovy little interface here. Now, the thing is, if I start asking it to do things, create files or whatever, it can't do that. So that's where our tools are going to come in. Let me move this out of the way. We are going to need to bring in a couple more things. So we got generate text. We got this guy. From AI, we're going to bring in tool, and we're also going to bring in Zod schema, which is just a shortcut available to us from the AI library that makes it easier for us to define these schemas very quickly. We're also going to import Zod itself. So Z from Zod. We are going to need a way to spawn a command line. So import spawn sync. Okay, I think this is probably all we need. We'll see. I'm gonna drop something in here that I sketched out earlier, and that's gonna be block commands. We kind of don't want it to run some of these commands, so we'll have that there. Now, when we get to our tools, we're actually going to structure this in 2 ways. We're going to have our actual code, so that's going to be like a function called run bash, which is going to be what our tool can run. So we'll have that, and then we'll have this object called tools where we could add more tools to it later. And the first one will have a key of bash, and then it'll use the tool command from the library. And that'll take in an object. It'll have a description. I'll say run a shell command. Now I have an input schema. So anti-gravity kickback, and that looks pretty good. So I'll have command, which would be z.string. And again, I'm going to tell that guy to shut up for a minute. Okay, so after the input schema, we're going to have our execute. And this is where we say, like, go run the thing. So async is going to take in a command. Command be a string. And then all we got to say is const, we'll call it output, is equal to run bash command. And then we'll just return the output. There we go. Okay, so we got our tools, and in the end, we are going to come down here and say tools. So that's how we're going to get that to our agent loop. Okay, so now we need to write this run bash guy. So we just saw that it's going to take in a command, which is going to be a string, and this guy is going to return a string. Then we're going to say if, what do we call it, block commands. So first thing we want to do is make sure we're not running some of those commands. So some. So if we have that, then we are just going to return, we'll just return a string with an error. Danger, little Robinson, whatever. Okay, so now we want to actually run our guys. So we're going to do a try catch on this. So catch our error. We'll return there. I'm not going to worry about this syntax right now. Okay, so now we just need to get our actual result, which is going to be, now we're going to use that spawn sync. But we just break out the command, so we're going to run shell, and then we're going to run taxc, which is going to be our command, and then the actual command. After that, we have some options to tell it where to do all this. So we're going to say our current working directory is work directory. We're going to say our encoding is UTF-8, and we're going to set a general timeout here of like 2 minutes. Yeah. Okay, now where did I... Now result equals, here we're going to return. We're going to concatenate our result standard out, and if we have it, our result that standard error. Trim those guys up, and then we'll make sure that we're inside of, let's say, 50,000 characters. Otherwise, we'll return nothing. That looks good to me. I'm sure I messed something up. Let's see. I got some missing. We don't need that. There we go. Let me clean all this up. Okay, so we've got a run bash, which hopefully works. We've got our tools, so we've got bash. And then here we're going to say use bash to solve tasks. Act, don't explain. All right. I think I don't know. It's worth a try, right? Okay, we're going to zoom this terminal way in again. We're going to say bun, run, index. We get our input. Let's start with a simple one. What is 2 plus 2? Cool. Now we're going to try to do something. So let's say we're going to create a file called hello.ts. Its content should be a function that logs out hello world. We'll see how that goes. I don't have high hopes, to be honest. Yeah, you know what? That looks pretty good to me. There's our hello. Whoa, let me zoom this way out. Okay. It's a function. It does what it's supposed to do. Cool. So what have we done? We've created an agent that can use tools. We've got an agent loop that'll run through until it's done. It uses bash, and we can add a whole bunch more to this. But one thing I am going to do is show you, I mentioned earlier on that I had this whole bin thing set up here so that I could use it in other places. So what we're going to do is kill this, and then I'm going to say bun link. And now my Jeeves project should be available in other directories. So what I'm going to do is bring up a separate terminal here. And I'll zoom this guy way in so you can see. And I'm just going to say make directory test Jeeves. And I'll zoom that in a bit more, sorry. Okay, so we'll go into this test Jeeves directory. There's nothing in there. It's empty. And so what I'll do is I'll say Jeeves. and there's my input. So now my working directory is testg. So if I say create a file called, I'll just use the same one I did earlier. Open up a new tab and list that out. There's our hello TS, add hello TS, and there's our function that says hello world. So this works. I can take it around. I can add a whole bunch more tools. And there's actually, I think I'm going to follow up on this video with another one where we do explain why you might want more than just bash. There is a world where some people say all you need is bash, but there are certainly reasons you might want more specified tools. In a previous video, we created our local agent loop using Ollama as our open API-like API. We've only got one tool in here called run bash, and everything here works great. Now, what we're going to do is create some more specific tools. Run bash is awesome, but we may run into limitations, so we want to create a way to specifically read, edit, and write a file. And the first thing I'm going to do is create a new file called tools.ts. And I'm going to bring in all of our tool stuff. I'll bring in some extra things, and then we'll clean that up. Don't need this. We're going to need our working directory and our block commands. Don't need the API. There is our tools, which we're going to export. And then, let's see, we need this. Don't need that. We don't need that right now. And we don't need this yet. We might need it though. Okay, so that is our bash tool kind of recreated in an external file. So we'll say import tools from that file, and then we can get rid of all of this for the time being. And we don't need that. And at the moment, we don't need either of these. We don't need that guy. Okay, so all that's cleaned up. I'm just going to double check that it works. All right, so we got 4. Our agent still works. And jump over to tools. And like I said, what we want to create is a specific tool for reading, writing, and editing files. So we're going to start with our, we'll call it run read. It's going to take a file path, which is a string, and then an optional limit, which is a number. So limiting the number of lines that the agent wants to read. All of these are going to be wrapped in a try catch. And the error will just return there. So now in the try, we're going to say, we're going to have this FP because we're going to write another function that makes sure we're inside of our working directory. But for right now, I'm just going to say that's equal to file path. And then we'll get our lines. That's going to be, we're going to need to bring in node file system and node path. So here, this will be fs, our file system, dot read file sync, and that'll just be our file path, basic encoding, and then we're going to split that guy on the line breaks. And then we'll just return, depending on whether or not we have a limit. So if we have a limit, say lines.slice 0 up to the limit. Otherwise, it'll just be the lines. And then we're going to join that back together on the line break. And then we're going to internally just say that we're not going to go over 50,000 lines. Okay, so there's our run read. Now we're going to come down here to our tools. And I think for the most part, this is going to be very similar. We can use that as a template. So this would be read file. Our description will be read a file. Our schema is obviously going to be a little bit different. So we're going to have our file path, and then we're going to have optional limit. Then our execute is going to rewrite that guy. So execute, take in our file path and our limit, and then just call run read with the file path and the limit. Okay, so there's our read file tool. Now we're going to follow suit with our run write and run edit. So let's do our run write. It'll be very similar, except we'll have a file path and content. So that's what the content that we want to write to the new file. First, we're going to make sure we have a directory to write to based on the file path. We'll say path.dirname of file path. We'll just say recursive true to make sure that we get down to any nested directories. And then we'll write our file. So write file sync. That's going to be our file path and then our content. And then we'll just return that we wrote the file. We'll add the file path in there. And while we're here, we'll go ahead and do our edit. So run edit. This would be a little bit different. So we're going to have old text and new text. So we've got a file path. We know what the old text we're looking for, and we're going to replace it with the new text. And say our content is going to be read the file. And we're going to say if the content doesn't include the old text, and we'll just agree with the AI here. We're just going to say that we didn't find it, and then we're just going to say let's write the file. So we've got fs write file sync, we've got our file path, and then we're going to say content dot replace old text with the new text. And we'll say we edited the file. Okay, I think this is looking pretty good. Now we're going to add these to our tools. So we'll just copy this read file, and we'll make write file. Say write a file. Got our file path, got our old text, and our new text. So this will be file path, old text, and new text. And then we'll just pass those into run write. You know what? I was actually doing our edit tool, so I'm just going to switch over to that. So this is our edit file, edit a file, and run edit, which is going to make it really easy to do what I meant to do, which is write file. So write file is going to be there. Say write a file, and then this will just be content, and we don't need this guy. This will just be content, file path, and content, and run write. Okay, so we got to read, edit, and write. We've still got our bash. It's a perfect fallback, and all of this is looking pretty good. We're going to jump over here, and we're going to say, instead of use bash, we're going to say use tools to solve tasks. And that's it. That just says go in, look at your tools. Now, there is one other thing I was going to do here, which is I mentioned it on these fp equals file path. We want to make sure that we're in the working directory. So we're going to create a quick function here called safe path. And it's just going to take in the path, which is a string. And we're just trying to make sure that we're in our working directory. So we'll say const resolved. We'll use resolve to make sure that it actually exists. So we'll say workdir and the path that it's looking for. So that should be path.resolve. And then we'll say if the resolved path doesn't include the work directory or it doesn't start with it, then we know we have a problem. So we'll say resolved dot starts with, and here we'll just return you know what we'll do, we'll actually throw there. So we'll say throw new error, path is not in. And if we're all good and that hasn't happened, all we got to do is return resolved. And then on each of these guys, we're going to say the file path is safe path around that guy. So I'll just copy that into each one of these. Okay, so now our guy is going to use any of the available tools. We've got read a file, edit a file, write a file, and then we've got run a shell command. So if we come back in, whoop, got a issue on that safe path one. There we go. Try that one more time. There's our input. And we're going to try our create. So this is going to be our write of file. So create a file called greet_ts with greet name and string function. Cool. It says it created it. We'll look at greet, and sure enough, there it is. And then we'll try our edit. So I'm going to say edit it and add some comments at the top of the function. And we can see it did in fact add those. And now we're just going to do a read. So I'm saying read it and verify the edit worked, which means it's going to have to use our history to keep the context of the conversation. And that's something that we built into this last time. Awesome. So there you go. We have isolated our tools away from our primary agent loop, and now we just import those. Clean this up really quick. We've added 3 new tools. On top of the existing bash tool, we've got a read, write, and edit tool available to our agent loop. In this video, we are going to teach our local coding agent to deploy sub-agents. To do that, I'm going to need to take some of this stuff out of our index. I'm going to create a new file here called config and drop all that in. And we will export all these. And we'll jump back over here and we will import from our config. Let's see, Ollama, model, and work directory. And actually, I'm going to rename Ollama to API. I just like that better. And we could potentially later decide we want to switch this over to OpenRouter or some other OpenAI-like interface. Okay, so we've got all that set up. We're going to jump into our tools. We're going to bring all those guys in. Let me close this sidebar. So here we no longer need this guy. And what we're going to do is we're going to create a new tool. I'm going to come down here after all the tools. And I'm going to create a new executable here called run sub agent. It is going to take in just the prompt, which would be a string. It's going to return a promise of string. Okay, and this is going to look a lot like, as a matter of fact, I can probably just go copy it. It's going to look a lot like our regular agents. Let me copy this out of here just to keep us moving. So we've got our text from generate text, which we're going to need to import. Now for messages, we're just going to hard code one. It's going to be role user, and the content will be the prompt that was passed in. Now here, we're going to say you're a coding subagent and complete your given task, then summarize your findings. Yeah, that way we're more likely to get something back. And we're going to bring in is loop finished there. So model name, is it not actually model name? I think it's just model. Yeah. Okay, so we've got our new executable. And now what we're going to do is we're going to export parent tools, which will be tools plus a new one. We'll call it task. That'll be a tool. Into our description, spawn a sub agent with fresh context. It shares the file system, but not the conversation history. We'll have an input schema just like we have with the rest of them. It'll be our Zod schema be a Z object with a task, which is a Z string. And on our execute, we have an async function, takes in the task, this returns await run subagent task. Clean this up. Now you may be wondering, like, why would we do this? The reason we're doing this is if I ask it to do something, if I ask our AI to do something, go look at a bunch of files and summarize them, the context window is going to blow up with reading all of those files, whereas I just wanted the summary. So what the AI can do is pass it off to a subagent, have it go do all the reading and the summarizing, and then just pass that summarization back up to the parent agent. It becomes part of our history, but we didn't blow it up with a whole bunch of stuff that we don't actually care about. So just to prove that this is working, what I'm going to do is I'm going to take away all the other tools from the parent agent, and I'm only going to give it the task. So it only has that one tool. It basically has no choice but to use that. So that'll be fun. So parent, we'll come down here, run our index, see if I didn't screw anything up. And actually, before we do that, I'm going to come back over here. Let me just stop this for a second because we want to actually see that it's occurring. So on this async, we're going to break that out. We're going to return the same thing. But here we're going to console log subagent and the task, just so that we see that firing off. Okay, so let's give this a try. What I'm going to say is read all the TS files, exclude node modules, and summarize what each one does. So we're expecting to see it fire off its first subagent. Cool. So it fired off a subagent, told it more or less exactly what I told it. Okay, so here is a summary. We've got the config, the index, the tools, everything's here. So it did it. But it's important to point out that our parent agent, again, didn't have access to bash or read or write or edit or anything like that. So it had to utilize the subagent. But at this point, we can turn the tools back on and everything's back to normal. It can use any of the tools it feels are important. And we can also tell it specifically, delegate this or use a task for this specific task. So now our agent can fire up other agents. One of the problems we can run into with our coding agent is on multi-step tasks. So you've got 5 steps, right? Maybe it takes 2-3 refactors per step. And by the time we get to step 3, the AI is wandering around. It doesn't know what it's doing. It's starting to improvise because it's kind of lost the thread. So what we're going to do for Jeeves, our coding agent, is we're going to create a to-do list. There's our to-do TS. I'm going to drop in some initial setup stuff here. So we've got a to-do status, just a string union, a to-do item, kind of the standard elements of that. And these little marks here are just to allow us to output this to the screen in a way that we can visually make sense of. So we're going to set up our to-do manager. We're going to initialize our items. And we're really only going to have 2 methods here. One's going to be update, and the other is going to be render. And at the end of every update, we're going to call this .render. And into our update, we're going to get our items, which would be a list of to-do items. Then we're just going to have a couple guardrails in here. So if our item's length is greater than 20, we're going to throw a new error. Max 20 to-dos allowed. And that's going to keep us from building up a list of too many to-dos. Now we're going to take a look at how many items are in progress. We want to make sure that our AI is only doing one task at a time. That's going to keep us, if we have a list of 5 tasks, it's going to keep us moving through that list sequentially, one at a time. So we'll just filter that. on the status of in progress. And if it's greater than 1, we're also going to throw an error. We'll break this out a little bit. And if all that's good, we'll just say this.items equals items. Okay, so now we can move on to our render method. So first we're going to check to see if in fact we have any items. And if we don't, we'll just say there are no to-dos. Okay, now we're going to build up our list for displaying in the UI. So list, we'll map that guy. We'll get our mark and our ID and our text. We'll just join those with some line breaks. Then I'll just get a quick summary. So we'll say how many are done, right? We'll filter uncompleted and get the length of those. And then we'll return our list of how many there are completed. Okay, so that's our basic to-do manager. I'm going to save that. We're going to jump over to our tools. We'll bring in our to-do manager and our type of to-do item. And right here at the top, we're going to initialize our new to-do manager. And then we're not going to need to do like a run to do because all of that is managed in the to-do manager. So we're just coming down here to our list of tools, and we're going to have a new tool called to do. It's going to be a tool just like the rest of them. It's going to have a description. That'll do. It's going to have an input schema, which I'm going to paste in here because I keep messing up the typing. But it's our Zod schema with an object that is the items, an array, and then just the object of our to-do items, the ones that we just defined. So then we're going to have our execute. It's going to be an async, taking our items. And then we're going to grab this just so that we can console log it. So output equals to-do dot update items, which will trigger render. And then we're just going to console log to-do line break and output. And then we will return the output. Okay, so that's our tool. We're also going to jump over to our index and we're going to update our system prompt. I'm just going to drop this in. So we still have your coding agent at work directory, but we've added this guy. Use the to-do tool to plan multi-step tasks, mark in progress before starting, completed when done. And then we still have our use the task tool to delegate, and create subagents later. Now, one thing we are going to add here is a brand new hook, and that's going to be on step finish. Now, there's a bunch of things we're going to get out of here, but what we want is tool calls. So that's letting us know if the AI has called a tool. So now we need to look and see, did it use the to-do tool? So we can say tool calls dot sum tool call dot tool name is equal to do. Otherwise, use to do is false. So what I want to do here is keep track of how many times it's used the to do and remind it to update its to dos. So up here, I'm going to say cycles since, or let's say steps since to do. Whatever. It doesn't matter. It's just an integer that we're going to track. So now we're going to say steps since to do is equal to, if we just used it, it's going to be 0 because we just used it. So we're trying to see since we've used it. So use to do 0. Otherwise, we'll say steps since to do plus 1. And if our steps since to do, let's say it's greater than or equal to 3, into our messages, we're going to push a reminder. So again, our messages are just objects with a role and content. So our role is going to be user. We're the ones reminding it. Whoops. Our content is going to be reminder, update your to-dos. Okay, I think we're looking good. We are going to try this guy out. I'm going to come down here. Now I've got what I hope is going to be a good prompt. So we're going to run our index. Now here's my prompt. Create a file called hello, add types, comments, guards, then create greet, add types, comments, guards that uses hello TS along with a node readline to accept a name for the hello function. This might not make a bunch of sense to the AI. I'm not sure what it's going to output, but I just wanted to have something that seemed to have a bunch of steps. All right, I'm going to run this and hope that I didn't screw something up. Oh, I got an undefined in there on the to-do. I'm actually going to go ahead and stop this and look at where we might be getting that undefined from. So that was when we were logging it out, which is going to be in our tools. Our output was on the to-do update. Come back here. This should be return this dot render. Okay, I think we're good now. Try this one more time. And to be clear, that probably wasn't going to be hurting anything. I'm not sure, but better safe than sorry. Okay, so we've got our list of 2 to-dos. It's working on number 1, and 1 is completed, and now it's working on task 2. So we'll look at this. Yeah, I created a pretty reasonable, kind of overly engineered version of that function. And now task 2 of 2 is completed, and then it's going to come back with a summary. So there we go. Our AI, or our coding agent, now has a basic state/task management system that'll help keep it on track. Okay, so we've got our agent loop, we've got a to-do tool and a subagent tool. And in this video, we are going to add a persistent disk-based task system. So unlike the to-do, which is for short checklists, this will be for long multi-step processes that we can return to in a new session. So to get us started, I'm going to create a new file here called task.ts. And I apologize in advance. I'm going to drop a bunch of stuff in here. Okay, so we've got file system and path. We've got our work directory from our config, which we set up previously, which is just our working directory. We've got marks and to-do status, since it's going to be the same completed, pending, and in progress. So we'll just mark that as task status, and we'll export that if we need to, just to distinguish it between the two, task versus to-do. We've got our type of task, which is ID, subject, description, status, blocked by, and owner. And the blocked by is important because unlike our to-do list, this isn't necessarily sequential. This is going to be a dependency graph. So they're not necessarily, the AI isn't to grab things based on the order or the ID. It's based on what it's blocked by. So if you have task number 3 and it's blocked by task number 2, you have to complete task number 2 before you can start task number 3. A couple consts here, just a prefix. Our file name is going to be task underscore and then the ID, and it's going to be a JSON file. And then this is our task directory that the class we create will create in our working directory. And then the rest of these are really just one-liners. Get the task file path based on the ID. So it's task file prefix, the ID, and the extension in the task directory. Read the task file. So same thing, just takes in the ID, uses our task file path to parse that out as JSON. Write a file, again, just the ID, get the path, write out the JSON. Validate a file. So we're making sure it starts with and ends with the prefix and extension. last task ID is dependent on this guy down here. So it's really just going to scan the directory and get the very last, latest ID. ID from file name. Stupid simple, just parse the int, get the number between the prefix and the extension. Task label is just going to output. It's just something I can use to save some typing. So it's just the status, the ID, the subject, and this B is going to be if it has things that it's blocked by. And then scan task files, again, sort of a one-liner. I broke it out, but it's read the directory, filter on the valid task file names in case we get like a weird DS store or something like that in there. Get the IDs, and then make sure it's not null, so it wasn't a weird file, and then sort those on the IDs. And that's the end of our helpers. So we're going to get started on our class here. It's task manager. In our constructor, we're just going to make that directory. So make dir sync. And we're just going to use our task dir, recursive true. So what we're going to have here is a create method, a get, an update, and a list. So I think these are relatively self-explanatory, but the create is going to create a task. So it's going to take into it the subject and the description. Both of these are going to be strings. We're going to say const t is a task, which we defined up above. Our ID is going to be that last task ID plus 1. We'll drop in the subject and the description. It's a new task, so we'll default to pending. Our blocked by will be an empty array. And then our owner, which we're not really going to use today, but we may touch on later, it's just going to be an empty string for now. Then we're simply going to write our task file, the ID, and the task. And then while we're in here, we'll just go ahead and return that guy as a JSON string. Okay, so that's the end of our create. We'll move on to this get. And this is going to be super easy. It's going to take in an ID, which is a number, and it's going to return a string, which is going to be the contents of the task file. So we just pass ID in there, we JSON stringify it, we're all done. Okay, update. This one's a slightly more complicated function. We're going to have an ID, which is a number. We are going to have a status, which is a task status. We're going to have add. This is really just short for add blocked by. So add a ID of a task that this is dependent on. And then a remove, which again is the opposite of that. Remove a dependency. This is no longer blocking this current task. I'm going to break these out a bit. This guy is going to return a string. Okay, so first thing we're going to do is get our task. We just need to pass in the ID for that. And we're going to see if we did get a status, which needs to be optional here. And we'll say t.status equals status. And then we'll also say if the status is completed, we need to clear the dependency. So I lied. We're going to have one other method. And we're going to say this.clear dependency and pass that ID in. So let me just sketch that out really quick. Okay, so we'll get to that. So if we have add, that means that we are adding a blocker. So t.blocked by. What we're going to do is we're going to create a new set, spread our current blocked by in there, and then drop in our new ones. And that way we have unique values. So that's all we're doing there is we're saying merge these two things together, the add and the existing ones. Then if we have remove, that means we're removing a blocked by. So blocked by equals, and then we can just filter that. And we say just remove any of them, or filter these down to the ones that are not in the remove. And then finally, we're just going to write the task file. with the updated task, and then we'll return that guy. Okay, there's our update, and now we'll do our list, which is really just formatting this out for the purposes of displaying in our terminal. So we'll say entries equals scan task files, and then we'll return as long as we have a length. We'll map that, call this task ID. Otherwise, we'll return no tasks. Okay, so let's do this map guy here. We'll get the task. We'll see if we have a blocked by length. And if we do, let's just go here. And we'll say blocked by these guys, so we're just JSON stringifying that. Otherwise, that'll be an empty string. Then we will return, using that task label thing I showed earlier, the task and the blocked by. Okay, that is our list. And now we're going to do this clear dependency guy, which is relatively simple. We're just going to say for, say const tid scan task files. So that's all of our files, and we've got all the IDs of those guys. Then we'll say T is read the task file. Then we'll just say if we have the ID in our blocked by, we just want to clear that. So we can kind of just copy this guy. I don't know if that's exact, but we'll drop that in there. And we'll say filter by b not equal ID. Okay, so that should clear out this ID from this task's blocked by. And then we'll just write the new task file. Okay, that is, I'm sure I messed something up in here, but that's looking pretty good. We've got task manager, we can create, we can get, we can update, we can list, and we can clear the dependencies when we move to completed. So now we're going to jump over to our tools and wire all this up. So we're going to bring in our task manager. Looks like we're not using this to-do item. Clear that out. And we're going to instantiate this. So const, just say task equals new task manager. So that's fired up. We'll come down here to our list of tools, and we're not going to need to do like a full executable like these run edits and run write, because it's all handled in the task manager, very similar to what we did with to-dos previously. So we're going to come down here. We're going to end up with 4 of these. So we'll start with task create, which is going to be a tool. It's going to have a description. Figure that out in a second. It's going to have an input schema, which will use our Zod schema. And it's going to have an execute, which will always be an async function that does something. So there's our template for task create. I have one for update, list, and get. Okay, so this will be create a new task, be update a task. This will be list all tasks, and this will be get a task by ID. Now for each of these schemas, we're going to be passing in the arguments that we need. So for task create, we have the subject and the description, and then we pass that into task create. So if we come down here, this guy is a bit bigger. We've got our ID, our status, the blocked by and add blocked by and remove blocked by. So let's let AI do that for us. So task ID, status, add, remove, and then we just pass those in. Down here, Zod schema is just going to be an empty object, and we're going to call task list. And then on this guy, we're going to pass in the task ID, and we're going to send that over to task get. I'm going to format all this. It's a little cleaner. And the other thing we're going to do is jump over to our index. We used to say use a to-do tool for multi-step planning, yada, yada, yada. Now we're going to say prefer task create, update, and list for multi-step work, and then use the to-dos for a short checklist. So we're going to try this out. I'm going to bring up our terminal. I'm also going to open this window here so that we see our task folder get created. On run index, and we can see our task folder has been created because we fired up the task manager. I'm going to say create 3 tasks, set up project, write code, write tests, and make them depend on each other in order. So 2 depends on 1, 3 depends on 2. Cool. So we have our 3 tasks. There's our first one, it's not blocked by anything. Our second one is blocked by task 1. And our third one is blocked by task 2. So now I'm going to say complete task 1 and then list tasks. Cool. So we have our setup was completed. Write code pending was blocked, but now it's unblocked. Write test pending, blah, blah, blah. So it's looking good. Now the cool thing is we can say exit our session, start a new session, say list tasks, and we should get a list of our tasks. There they are. This says complete, but this write code one still says blocked by task 1. So it looks like we did not clear out. Okay, so we didn't clear out the dependency. I screwed that up. So blocked by is equal to that guy. So what I'm going to do is I'm just going to start all over. I'm going to delete the task directory, kill this. We will fire up a new session, give it the exact same command. So we can see our task created just as before. 2 is blocked by 1, 3 is blocked by 2. I'm going to leave 2 open, and we're going to say complete task 1, then list tasks. And I think we should see this. Oh, there it goes. Yeah, so that worked. We will clear this out. We'll load it up again and say list tasks. And there we go. So 2 is no longer blocked by 1. 3 is blocked by 2. We now have a disk-based persistent task management system. One of the things we need to be aware of in our local coding agent is context, or what we call tokens. The way that we generally measure tokens is you just take all the messages and divide them by 4, and that means every 4 characters is a token. So what I did is I created this estimated tokens here in this compact file, brought that into our index, and right here at the beginning of our loop, I said, give me a token count. And just to show how this works, I'm going to try to do something that generates a lot of tokens. So I'm going to say, give me 50 writing prompts. So just that was 14 tokens. So after this comes back, I'll ask it something trivial and we'll see what the current token count is. Okay, so we got our 50 writing prompts, and I'll just say, what is 2 plus 2? And our token count is approaching 1,000. So in memory, we have roughly 4,000 characters in our message history. So what we're going to do here is we're going to compact that history. And we're just going to automate it. So it's not going to be a tool that the agent needs to use. We're just going to do it. We're going to set it to automatically happen. So in my config, I'm going to create a new const called context limit. I'm going to set it to 50,000. We'll bring all the stuff in that we need. So we've got generate text, we've got our model, our API, and our context limit. Now we're going to have a couple internal ones here. So keep recent is going to be 3. I'll explain that in a second. Then we're going to have const preserve tools. And that's going to be a set And for right now, we're just going to be preserving read file. So these are specifically about tool calls. I'm going to go ahead and keep the most recent 3 tool calls. And we're always going to preserve read file. So the thinking there is that when we read a file, it's actually referential information. It's potentially important. So let me just rearrange this a little bit, put these guys at the top. Okay, so estimate tokens is going to stay, and then we're going to have 3 other functions. We're going to collect tool results, and we're going to have micro compact. So this one's actually going to run on every call through the LLM. Then we're going to have an auto compact. An auto compact is going to be when our message history has gotten too big. I'm going to drop in a little type here and close this sidebar. Okay, so the type is actually just what our messages look like. And I do want to mention that when the content of a message is just a string, that just means it's text. There's nothing there for us to really concern ourselves with. We'll concern ourselves with it in the auto compact, but not in the tool results or the micro compact. So we're going to ignore those when it's just a string. What we're looking for in the collect tool results in micro compact is tool calls. So that content won't be a string. It'll actually be an array of what very much looks like our message history. So it'll have a type, potentially a tool call ID, a tool name, and a content. So we'll start with our collect tool results. This guy is going to get our messages, which is an array of model messages. And what it's going to return is a part with content, which for now will be unknown, and a tool name, which should be a string. So we're going to gather those names in a new map. We're going to return. We're just going to do all this very functionally. So the first thing we're going to do is flat map this guy. And we're going to say if our content is an array, I'm going to return that as an array of parts. Otherwise, just an empty array. Now we're going to reduce on that. We have our accumulator and we'll call it P for part. So first, if our p.type equals tool use, here we can get the actual, or we should be able to get the tool name. So let's make sure that it has a tool call ID. And if so, we'll say names.set, call ID, and the tool name. So now we'll look for tool results. So let me just copy this. So if a tool result, and we have the tool ID, we're going to push into our accumulator a new object with our part and our tool name, names.get. And in case that's not there, we'll just say unknown. We'll return our accumulator. And then down here, we will have our array as, not tool. It's going to be that guy. And that should be an array. Okay, so that is, now we've got our names and we've got our tool use and result in our accumulator. So now we get to our micro compact. And we're going to call collect tool results with our messages, which we're going to plug in here. This isn't going to return anything. On that, we're going to slice 0 to minus keep recent. So we're keeping our most recent 3. And we're just going to for each those guys. Get our part and our tool name. And we're going to have a big old if condition here. So we're going to say if not preserve tools.has tool name. So in our case, if this isn't read file, if the contents string, And for good measure, we're going to check to see if the length is greater than 100. And if all of that is the case, we're going to say part.content equals, and we're just going to say previous used tool name. So what we're doing is we're actually replacing that message in the history with used tool name. So we're just throwing it away more or less. And we're just keeping a reference that it's there. The rest of the structure for the way that AI SDK works with this is still in place. So we're fine there. We haven't broken the history. We're just stripping out that content and saying this was the result of a tool name or whatever. We still keep track of what tool was called, the order in which it was called. All of that remains intact. The message history is there. It's just really that the results of this guy are stripped out, and we just say we use this, and we don't really care what the results of it were. Okay, and then for this, what we're going to do is we're going to bring all this into our index. And at the very beginning of each of our interactions, we're just going to drop in micro compact messages. So it's just going to strip out everything except the last three, and we're also excluding read files. So everything else, long bash outputs, catting files, all that stuff is going to go away. Okay, so now we have our auto compact. If you notice, I brought in generate text or model, all this good stuff. Oh, you know what, this context limit, oh, we're not using that yet. Okay, so all those things we haven't used yet. And what's groovy about this is we're actually just going to use the LLM to summarize all this stuff. So we're going to take in our messages. Let's model messages again. And here we're actually going to use the AI. So await generate text of our model, which is our API.chat model of our messages. And we've done all this before, so I'm not explaining a bunch here, but this is how we interact with our Ollama service. So we're passing in the model, which we've already got in our config, and now the messages. We just got done iterating through a bunch of those, but this one will just be a user message. So role user, and then the content is going to be this right here. So it's pretty long. Summarize this conversation for continuity, include what was accomplished, current state, and key decisions made, be concise. And then we just pass in all our messages and slice it. We slice it to the context limit. That's it. And then we're going to return a new message history. That's it. So let me just grab this. Instead of that content, I'm going to say conversation compressed. Here's the text. Otherwise, there's no summary. And that is all there is to that. We are going to jump back over to our index. We're going to use our estimate tokens. We're going to say if estimate tokens messages is greater than the context limit, say const compacted is equal to await auto compact, pass in our messages. And then we're going to make sure we clear that out by saying messages length equals 0. And then we're just going to push all the new ones in there. Clean this up. And that's everything. So on every call, we are going to do this micro compact, make sure that our tool calls are getting reduced. We're always keeping those last three, and we're always keeping read file. And if we hit the context limit, which in our case is 50,000, we are going to automatically compact those messages. Now I'm going to pause the video here while I try to figure out a really good way to show that this is occurring. So I did two things here. One, I dropped our context limit down to 3,500. And the other thing I did is I just reworked this a little bit. Get our estimated tokens outside of the check, console log out what our tokens are. And then we do our compacting. And what I did is I log out, we're compacting at, and then console log our new tokens. So 3,500 should be pretty easy to hit. So I'm going to say, give me 100 writing prompts. So we're at 14 and a quarter. Okay, so we'll ask it something simple now and see where we're at. So we're at 1648. So give me 200 more writing prompts. Okay, there's our 200. Let's see where we're at. Okay, so we were at 4,443 tokens, and it's compacting now. And again, remember, in this case, it's actually firing off a new request to the LLM in a new session to summarize the content of those messages. And our new tokens are down to 122 and 75. So there you go. We are automatically compacting all of our message history. We went from almost 4,500 tokens down to 122. And you can see from its response here, it clearly hasn't lost any of the thread. It's still talking about the writing prompts from our message history. So there you go. We could essentially assume that we could work on a large code base for, if not forever, a very, very long time with this new compaction without concerning ourselves about the context getting too large. So until now, our entire interface has been readline and this recursive prompt function. And our UI kind of sucks. So if I say explain task.ts to me, couple things here. We do not have the ability to put in multi-line stuff without it getting weird. We certainly can't like shift enter. The response that we're going to get back here is not going to be formatted at all. And at this very moment, we have no idea what the AI is doing. So there's our response. Again, no formatting, and we're back to our pretty gross input. So we're going to solve that. I have installed pi-tui and Chalk. I'm going to create a new file here called ui.ts. I'm going to import a bunch of stuff here. So we've got a whole bunch of elements and components from pi-tui. We've got this component type. We've got our model message, Chalk, and this markdown theme guy. Now these themes control how the thing looks, and I'm just going to drop these in. I did not make these. These were something I found somewhere. So we got a UI theme and we got a markdown theme. We are going to export a class called agent UI that implements component. Now I've kept this code very simple, but there is a lot of it. So I'm going to do some pasting here. Okay, so we've got a couple internalized elements here. We've got TUI, which is our processor or process terminal from the TUI library. That is going to kind of translate our inputs and outputs for us in the terminal interface. We've got editor, which is a component, uses our UI theme, this padding X1. I think I got it from the docs. Thinking loader is going to be, it's going to help us solve the problem of not knowing what our LLM is doing. And current action is going to be a part of that as well. So rather than just a spinner that says it's thinking, when we have tools being called or results coming back, we want to have something there that says I'm reading a file, I'm doing something. And this MD cache is kind of poorly named because I'm not really doing any caching here. But this is just going to be a map over the markdown components that we're going to create. So markdown is a component. In order for us to express that in the UI and get into our message history, we're going to have to like feed it into and get it back out of a markdown component. And we've got this on input, which is kind of replacing our prompt that we had previously, our recursive prompt function here. But either way, we'll get there. Okay, again, I'm going to be just kind of dropping some things in here. We have our constructor, which is going to take in our history. So this is very similar to our agent loop. We're immediately going to add this to our TUI. So our agent UI is actually a component. TUI is the whole thing. So we're adding ourself to that, and then we're adding the editor to the TUI. Editor is going to get it on submit. And all I'm saying here is if we have a thinking loader, I don't want you to be able to input for now. I could circle back on that, but whatever. And if we do, then we're going to call our on input. We've got one input listener for control C, and that's just going to exit, and that's it. And then, of course, if we get an interruption or a termination, we're going to exit our application. Start, this is just part of the component definition, so we're going to start up our TUI. And this guy right here, I've had mixed results in getting the cursor to focus in the user input, which is what our editor is, by the way. We're utilizing that as the user message input. So I'm kind of setting focus twice here, but this has worked out for me. So I set it on the editor itself equal to true. And then in the TUI, I set focus to that component. And then our exit is just stop everything and exit the process. Okay, everything I'm about to drop in, I'm calling our rendering helpers. So we got a pen spacer. It's going to push an empty line into our lines. And if you remember, lines this is our history that we've always had. It's always been here. We're pushing in, and the messages, and I'm sure somewhere up here we probably did an empty line as well, just to create a little space in the UI. Coloring our messages, if it's a user, I want it to be green, otherwise I want it to be white. This is a render of the assistant message, and this is where we're going to use our markdown. So we check to see if it's in the cache, and if it's not, we are creating a new markdown component, and then we're setting that into our markdown map, and then we render that guy, or we return the render of that. Now, plain message is just get the message text, split it by the line breaks, and output it. We're using that color message. So if it's a user, it'll be green, and if it's something else, it'll be white. Then we have render message, and that's just calling those two functions. So if it's assistant, we're going to call render assistant message, and otherwise we're going to call render plain message, and that could be a user or a tool or something else. Now, pen thinking, we have our lines, and we have this width. And just to mention this width, no, we haven't used it yet. The width is basically the size of the screen that the TUI is more or less taking care of for us. So if we don't have a thinking loader, just exit out of this. Otherwise, append an empty line and then push into our history thinking loader render with the width. And then if we've got this thing called current action, and that is the thing I was talking about where I want to see if it's like reading a file or something like that. So we're going to have a little return line there, and then in gray we're going to have our current action, and that's just going to be like ephemeral. There'll be a little loader and a little gray thing that says this is what I'm doing. Fit width is mostly just a method, or I'm wrapping this. I want to get to this truncate to width right here. So we basically look at the line and we say if the visible width of the line, and this is a method that we get from the library, is greater than the width, then truncate the line to the width. Otherwise, just return the line. And then get message text. We've seen it a couple times up here. Okay, then after that, we're going to have our basic push, which is really the exact same as what we were doing before. We're pushing into the history. The difference here is we're also requesting that the TUI re-render, and we're updating the editor text to nothing. So we want to keep that in place and have, your message move into the message area and not remain in the editor. Then very simple functions, set action status. We're going to take in the action, set our current action of that, request a re-render, and then we've got a clear action, which just clears that out. We've got this make spinner guy, which is really just spinning up this loader component, adding the text of thinking to it. These colors here are, if I remember correctly, well, let's just see, they are the spinner color and the message color. Okay, so most of this is all just helpers to push information into into the history and update the TUI. So our last guy here is going to be think. It's going to take in a function that returns a promise of type. And that function is actually going to be our agent loop. So nothing really new here. What we're going to do in here is say this thinking loader is going to be this dot make spinner. So we've got our thinking loader, and we're going to call this dot clear actions. So we just got our agent loop just fired off. We're going to wrap all this in a try. We're going to have a catch, of course. And when all is said and done, we're going to have a finally where we clear our action status. On the error, we're going to clear out our thinking loader because we're not thinking anymore. We're going to say this dot history dot push, and this is just going to be yet another model message. So we're going to have role. In this case, it'll be assistant, and then content, which is going to be that guy. So if it's an instance of an error, return the message. Otherwise, stringify the whatever E happened to be. Now here we're going to say const result is our await function, and if you remember, it's the exact same thing we did in the index, which was reply. I'll call it reply await agent loop history. So here we're just going to say reply, and then we'll set our thinking loader to null, and we'll return our reply. And that should really be it. I'm going to format all this, and I know that's a lot of code, but everything, this is not there. It's missing invalidate, and we do need to do the render, my bad. Okay, so invalidate's a really easy one because it's going to be a no-op for us. You really end up, as far as I understand, you end up using this if you're going to be doing like streaming text to the screen, and I'm not doing that right now, so I don't really care. So I'm just going to make this a no-op. And then the other thing we need is our render method. So render is going to take in that width that I discussed. I'm going to say const lines is an array of strings initialized to an empty array. Let's say for const m of this dot history, so it's our messages. This dot append spacer, so we're going to throw in an empty line in there, and then lines dot push, this dot render message, and the width. So we get our message and our width. It'll figure out that render message will figure out if it's a user message or an assistant message. We don't have to worry about that. And we'll say this dot append thinking lines and width. And then finally we'll return this dot fit width, which we looked at a moment ago, lines and width. Okay, I think we're looking good. We are going to jump over to our index. We're going to bring in our agent UI. We're going to come down here, and for the most part, we don't really need, I don't think we're going to need any of this, but there's a couple bits in there that are more or less identical, and we do want to get those. So let's see, our history remains. We definitely need that, so let's keep that guy. And we'll initialize our class with new agent, or new agent UI is of history. And then we just need to set up our input. We're still going to do a few things here, but this is replacing our prompt and our read line for the most part. So on input, it's going to be async we called that query before. So just to point out, down here we had async query. We're doing the exact same thing. So async query. And to some degree, we are sort of doing this. So let me just grab these. I think we can just refactor them on the fly here. So this is going to be UI push, and that should all be the same. And then here we'll say if reply UI push the reply. And then this part is going to change. So we're going to say await UI.think. We're just passing in our agent loop. And we're going to add one more thing here. Into the agent loop, we're going to pass our UI, and I'll explain that in just a second. But for the most part, you know what, we are going to do our UI start. All right, I think that's pretty much it. Now, I mentioned that we're going to pass our UI into our agent loop. And the reason I want to do that is in order to get those little messages that I was talking about. Like, so we're not just sitting there waiting. There's our class, and then we're going to come down here into our on-step finish, and right outside, well, actually here we're going to get tool results, which we get for free from the on-step finish, and then right outside of this step since to do, again, I'm just going to drop this in. And what we're doing is we're getting that tool call. And if we have a tool call, we're going to stringify its input, cut that down to 50. Then we're going to get our output off of the tool results with the same index. And then we're building up this little string. I'm not a huge fan of emojis. Put a little red dot for an arrow or an error and a green dot for success. And then we're going to set our action status to the tool name, the arguments, and the result. And with that, let's see, we don't need read line anymore. And I think we can try this guy out. Okay, so we've got groovy little lines. We can see where our cursor is. I'm going to say, give me 5 writing prompts. We got a little thinking spinner. There's our writing prompts. I'm going to say, explain ui.ts to me. The other thing you can see here is we are getting our markdown formatting. So you can see lost library is in bold. And down here, we're getting our little actions, thinking and reading the file. Cool. So we got all those results. Now I did notice one thing. It was saying it was reading a file, but it wasn't saying what file it was reading. So I want to make sure that we're capturing that information. So I think it appears that anti-gravity was doing some weird stuff there and trying to overwrite my file. So we're going to try this one more time. And there we go. We get our file path and I am satisfied. So cool. Not an amazing UI, but we have the basic functionality. We have markdown formatting. We have a little thinking going on. It's a much better experience. At this point, our coding agent is pretty well rounded, but we do have this situation where every time we want to create a new tool or teach it a thing, we have to write it. So I'm going to take a note from the Claude ecosystem, and we are going to teach our coding agent to use skills. So I'm going to create a new file here. We've got our file system, our path, our work directory from our config. We're going to create this .skills directory, and we've got our interface. I'm going to export our class of skill loader. It's going to track skills, which will be a record of string and skill. Set up our constructor. We'll create that directory if it doesn't exist. And we're going to loop over everything in that directory. So we're reading the skills directory, And we're going to check to see if first it's a directory. So we only want to look in directories. The structure is going to be, we've got .skills, and inside of that we have folders for each of the skills, and inside of each of those they have to have a skill markdown file. So if not entry dot is directory, continue. Otherwise we're going to go find that skill file name, and then we're looking for skill.md. So if we don't have that, we'll just continue on. Otherwise, we're going to get the text from that guy. We're going to extract we're going to separate the front matter from the content. So we're going to have this.parse front matter method here in our class. We'll just pass it that text. So we'll make that in a second. Now what we got to say is name equals, from the meta, the name field. Otherwise, that'll just be entry.name. And then we say this.skills name is equal to the meta and the body. Okay. So let's do this parse front matter guy. Just going to return a skill. Let's drop this in there. I didn't make this up. I copied that from somewhere. It's a way to get the elements in to get that section of text at the top of the markdown file. So say if not match, and then we'll just return meta is an empty object and body is just the text. And from the match, we'll get the raw meta and the raw body. Say const meta is an empty object. And now we'll just loop over the lines of that raw meta. And then name and description are really all we need, and they should be separated by like it should say name, colon, and then the name of the thing. So that'll be our key, and then the rest. So if we have a key and the rest has a length, we'll say meta, we'll trim that key, and then this will equal, we'll join that guy, and we'll trim it. We'll have our meta be the record of string, and then we'll just return that. So meta and body will be our raw body, and we'll trim that as well. Okay, moving on. We're going to have a get descriptions method. The way we're going to use that is when we initialize our system prompt, we're going to let it know about any existing skills that might be in place. So we'll say const entries is equal to object.entries, this.skills. And if we don't have any of those, we'll just return no skills available or something. Otherwise, we're going to loop through those. We'll get the name and the record, and we'll return the name and the meta dot description. And we'll just join those back together with a line break. Okay, last one, get content, taking the name, return a string. The skill is from skills name. If we don't have a skill, we'll throw an error. Otherwise, we'll return nice long string explaining the skill. Okay, so we loop through our directory, build up all the skills. We're using this parse front matter to break that out. We've got this get descriptions, which we're going to feed into our system prompt, and then get content for whenever we need to grab an individual skill or have it read one of those skills. I'm going to jump over to our tools. We're going to import our skill loader. We're going to say skills equals new skill loader. We're going to get our descriptions out of the skill loader. Come down here to our tools And right after this task get, let's see if this guy's doing a good enough job. I do like that. I'm going to update this to load specialized knowledge by name. The schema is okay, and the execute. We might want to log some stuff out here, but for the most part, this looks like what we need. All right, so you'll notice that I exported the skill descriptions here. We're going to jump back over to our index. And from our tools, we're also going to get those skill descriptions. And right after this guy, we're going to say use load skill for specialized knowledge. And then here are the descriptions that are available to it. So I think that's all we need. We're going to try this out. What skills do you have? So we can see it created the skills directory, but obviously it's going to be empty. So cool. It came back and said there's called it skill get, which I'm fine with, but originally I wanted to call that skill load. So let me just update skill get. Okay, so obviously it doesn't have any skills, so we're going to create a skill. So I'm going to create a new folder here. I'm going to call it bun testing. And that I'm going to have skill.md. And I don't know where I got this from, but here's a skill. It's got a name. I don't care about this invocable. I just care about the description and the content here. So now we're going to see if it knows about this skill. Cool. So it knows about bun testing. So let's come down here and I'm going to say use bun testing and create a test for, we'll say, to-do.ts. Okay, I saw it reading the skill, reading the to-do file, and then writing a new file, and I can see to-do.test has shown up. Got our little reminder guys coming up in the UI, but I'm not worried about that. Okay, so it claims that the tests are done. Seeing some squigglies in there, but let's just see. This is all working okay. It's just a biome thing. So I'm just going to run the test myself in a regular terminal. Hey, they're all passing. So it took a little while, I'm not going to lie. But we just taught it a skill. And at this point, there's no reason to think that I can't bring in a whole bunch of different skills however I see fit. So I'm pretty happy with this. That is a solid step forward. We can just start bringing in skills that were meant for the Claude ecosystem into our coding agent.